When we're multiplying polynomials, we will need to take into account some exponent rules, and that would most likely be the power rule. So in our first example, we have 7y to the fourth, z to the fourth is multiplied by another monomial term. So 7 is multiplied by the other coefficient, -1. And then we have our string of variable terms. So I'm just going to rewrite those. Y to the fourth, z to the fourth, x, y to the 11, z to the fifth. So taking care of the numerical coefficient, I would have -7. I have y, z, x, y, z. So in alphabetical order, x comes first. We only have one base of x. So I'm writing that. That piece is done. Next would be y. I have two different bases of y. 4 and 11 are the exponents. So when I add those together, I would have y to the 15th. Last, I have base of z. 4 and 5 make 9. I have each base written one time, and each base is written with a positive exponent, so that problem is complete. And now in example 2, you can see we have plus and minus involved in each of these quantities. So I will use the distributive property to find the final product. I'll take x and distribute that to each term in the other quantity. X times 2x means I'm applying the power rule. So I have 2x squared. Then x is multiplied by -5, so that's -5x. My next distribution is +3 times each term in the other quantity. 3 times 2x is +6x, and 3 times -5 would be -15. So you'll notice here in the middle, I have like terms, and those like terms need to be combined. So I have 2x squared as my first term. -5 plus 6 leaves +x, and the last term is -15. So when I multiplied those binomials, I ended up with 3 terms for my polynomial answer. Here we have some more examples of multiplication, and I'll distribute 2x to each term. So 2x times 5x squared. 2 times 5 gives us 10. X to the 1 times x squared gives us x cubed. 2x times -6x would be -12x squared. Finally, 2x times 7 would be +14x. Then I'm distributing -3. So -3 times 15x squared would be -15x squared. So I'm going to write that below my other x squared terms to collect my like terms. -3 times -6x would be +18x. So see how that lines up with the other x. And finally, -3 times 7 is -21. So now that I have already collected my like terms, I simply go down the columns and combine them. So 10x cubed is the only cube term. With the squared terms, both coefficients are negative, so I'm adding them and keeping the negative. So that would be 27. So 10x cubed minus 27x squared. The first degree x, both are positive, so we're adding to get +32x. And 21 is the only constant term, so -21. Lining up these terms with their like terms right away it saves you a little bit of effort when you have to combine them. Now the last example here already is in the vertical format. So we have 4x squared plus 5x minus 7 multiplied by 3x minus 1. So I'm distributing 3x times each of the terms written above. 3x times 4x squared would make 12x cubed. 3x times 5x would be plus 15x squared. Finally, 3x times negative 7 is minus 21x. Now I need to distribute negative 1 to each of the terms that's written above. And it doesn't matter if I start by multiplying the negative 7 or multiplying with 4, but I'll just keep going from left to right. Negative 1 times 4x squared would be negative 4x squared. So I'm looking at the exponents of the terms I already wrote so that I can line this product up with its same power. So I had negative 4x squared. Then I'm taking negative 1 and multiplying by 5x. That would be negative 5x. So again, lining that up with its like power. And finally, negative 1 times negative 7 would be positive 7. That needs a new column of its own. So when I combine the like terms, I know that 12x cubed is the only cubed term. 15 take away 4 would be positive 11x squared. Negative 21 minus 5 would be minus 26x. And positive 7 is the only constant term. So automatically the terms are written from the highest to the lowest power. Here we have what are called special products because you can see that the binomial is raised to the power of 2. So that means we have two identical binomials to multiply. So we expand it first, and then you simply distribute like we've been doing. So 3x times 3x would be 9x squared. 3x times 5 is plus 15x. Next, you're going to distribute 5 times 3x to get 15x, and 5 times 5 for 25. Now do you notice here in the middle that the terms have doubled? And that's what happens with these special products. Sometimes the middle will double. So we end up with 9x squared plus 30x plus 25. The first term and the last term are perfect squares. And we'll talk about these perfect square trinomials in a later lesson. Now sometimes you have subtraction. So that simply means you are expanding this binomial. You have two identical binomials and both of them have subtraction. So when I distribute 2x to each term, I end up with 4x squared minus 18. And then I'll distribute the negative 9. So negative 9 times 2x would be minus 18x. And negative 9 times negative 9 would be plus 81. In the middle, you can see we have a doubling. It's just two negatives that are doubled. So the final product, 4x squared minus 36x plus 81. Again, the first and the last terms are perfect squares. In example 7, you'll notice that this is a little bit different from the other two because they are different symbols given in the binomials. One is plus and one is minus. Distribute like we have been doing. So we have x squared minus 6x, and then distributing 6 times x, that's positive 6x, and 6 times negative 6 would be minus 36. We do not have doubling in the middle. Negative 6x plus 6x eliminate. So we end up with x squared minus 36. This is called a difference of squares with no middle term. In the last example, 4x plus 3, is multiplied by a quantity of 4x minus 3. So they look identical, except one is plus, one is minus. What do you think is going to happen with the middle terms here? Let's distribute and find out. So 4x times 4x is 16x squared. 4x times minus 3 is minus 12x. Distributing 3, I have positive 12x and minus 9. So again, you might have predicted that these terms in the middle are opposite of each other, therefore eliminating. We're left with 16x squared minus 9. And both of these terms are perfect squares, so we have another difference of squares. We'll be working with some of these special products in later lessons, so I hope you'll recognize them later on.